The concrete furnace. India, a country on fire. Why is the world's fifth largest economy struggling to survive its own summers? As of May 2026, India is reporting temperatures between 43 degrees Celsius and 45 degrees Celsius. Not in June, but in April. States like Maharashtra, Rajasthan, and Odisha have already crossed 45 degrees Celsius, while Delhi sits at 44 degrees Celsius. The IMD warns of above-normal heat waves across 23 states. But while India burns, Bengaluru recently recorded 111 millimeters of rain in one evening. Does this mean Bengaluru is safe? No. It's a different side of the same crisis. Why India burns? The three-layer problem. Layer 1. Geography. India's position near the equator makes it sun-exposed, but the Indo-Gangetic Plains, home to 600 million people, act as a natural heat trap, with no mountain barriers to block hot winds. The Lu wind from the northwest routinely drives temperatures past 45 degrees Celsius. In 2026, a heat dome high-pressure system is trapping hot air over eastern India, while relief-bringing western disturbances have weakened. Layer 2. Human choices. Between 1981 and 2020, heatwave hotspots expanded dramatically. Deforestation is a primary driver. A single tree can cool an area by 2 to 8 degrees Celsius. Replacing trees with concrete creates urban heat islands, making cities several degrees hotter than rural areas. The cost? India is projected to lose 5.8% of daily working hours by 2030. In 2024, there were over 44,000 heatstroke cases. India is now 15% more vulnerable to heat extremes than in 1990. Layer 3. Global warming. El Niño and the 2026 La Niña have disrupted monsoon patterns and intensified pre-monsoon heat. Models show 90% of India will face uncomfortable warm nights by the century's end. Additionally, scientists are currently tracking a potential super El Niño for 2026, as sea surface temperatures in the central Pacific have already climbed rapidly. In simple, what we can expect out of it: extreme heat, monsoon disruption, and upcoming extreme weather for 2026. Bengaluru's local catastrophe. Bengaluru was once a 3,000-foot-high oasis. But in April 2026, temperatures are consistently 4 degrees Celsius above average, hitting 38 degrees Celsius in Whitefield and several areas. The 1,055% surge. Between 1973 and 2023, Bengaluru's built-up area exploded by 1,055%. We lost 88% of green cover and 79% of lakes. By 2025, 93.3% of the city became impermeable concrete and asphalt. This radiator effect increased surface temperatures by 7.9 degrees Celsius between 1992 and 2017. The water heat death spiral. Bengaluru has a daily water deficit of 500 million litres. In the east, extraction is 378% of the recharge rate. Dry soil can't regulate temperature, leading to a spiral. More heat, more evaporation, and deeper borewells. The Bengaluru paradox. Why is it raining? On April 29, 2026, Bengaluru saw a record 111 millimeters of rain. Why? 1. Altitude. At 920 meters, intense daytime heating causes warm air to rise and condense into convective evening thunderstorms. 2. Western Ghats. Southwesterly winds from the Arabian Sea push moisture into the Ghats, triggering instability and rain in Bengaluru. 3. 2026 anticyclones. High-pressure systems over the Bay of Bengal and Arabian Sea are acting as moisture pumps, pulling ocean moisture onshore. What's the catch? This rain doesn't save the city. Because 93.3% of the surface is concrete, water floods roads instead of recharging the water table. Lastly, let's touch on the road ahead. Our heat is a local choice. We built cities for a climate that no longer exists. To survive, we need mandatory 33% green cover for all new developments, restoration of paved-over lakes, a funded national heat action plan. The Garden City won't return on its own. Unless we act, the concrete furnace is our permanent future.